Our 11th problem goes like this. There are two lines given, or in fact there are four lines given. Y equals mod x minus 1 and y equals minus times mod x plus 1. Now you'll wonder how these are four lines, and we want to find the area which is enclosed between these lines. Now these are actually not two lines, there are four lines. We take case 1. If x is greater than or equal to 0, so this mod x will open as plus x and we get the line y equals x minus 1. First line. Our case 2, and similarly this mod x will open as plus mod x again and we'll get the second line y equals minus x plus 1. Now case 2 is obviously x less than 0, so we get this mod x as minus x, so we get the line y equals minus x minus 1. This is a third line, and this mod x will again open as minus x to get y equals x plus 1, which is our fourth line. So here we can clearly see these are not two lines, these are actually four lines depending on how x is behaving. If x is greater than or equal to 0, we get two different lines, and if x is less than 0, we again get two different lines. So here we have four lines. We can clearly see there are two sets of parallel lines. Y equals x minus 1 is parallel to y equals x plus 1, and y equals minus x plus 1 is parallel to y equals minus x minus 1. And these two lines are perpendicular to each other because its slope is 1, its slope is minus 1. So m1 m2 equals minus 1, and similarly these two lines are perpendicular to each other because m1 m2 equals minus 1. So here we get a closed figure. We can say this is y equals x plus 1, this is y equals minus x minus 1, since these are perpendicular to each other. Similarly this will be y equals x minus 1, since this line is parallel to this line, both are having the slope of 1, and this will be equal to the left line, which is y equals minus x plus 1, since this is perpendicular to this line. Now we can mark the four vertex A, B, C, D. On solving these two lines, we get x equals minus 1 and y equals 0. On solving these two lines, we get x equals 0, y equals 1. On solving these two lines, we get x equals 1, y equals 0. And on solving these two lines, we get x equals 0, y equals minus 1. So we can clearly see the length of side BC is equal to root 2. The length of side AB is again equal to root 2. The length of AD is again equal to root 2. And the length DC is definitely again equal to root 2. So here we get a square whose length of the side is root 2. So we can clearly see that the area of this figure is equal to side square, which is root 2 square, which is equal to 2 units. So these four lines are enclosing a square of length root 2, and area of this figure bounded by the four lines is equal to 2 square units.